Hi everybody, so today we're going to look at pH and indicators and continue on with these questions. So we're looking at 2011 question 7. Now I actually deleted some of this, so I'm only focusing on the maths part of the question. So there is more to this question than just what you see here, okay? But we're focusing on the maths for this one. So first one is to find pH. Well, there's a couple of ways you could do this, but I just prefer the normal formula. So pH equals minus log to the base 10 and then do your square brackets H plus. And again, I can't stress this enough. You must do those square brackets. Now, next part of the question is calculate pH of a weak acid. Okay, that's value, acid's dissociation value is 6.3 times 10 to the minus 5. Okay, and you're given the molarity there. Well, there's a normal formula for that. Is pH for weak acids equals minus log the base 10 square root your Ka multiplied by your H plus. That's your molarity there. Okay, so we're going to fill in our information there. pH equals minus log square root, and we're dealing with 6.3 times 10 to the minus 5, and I put these in brackets multiplied by 0.2. Close the brackets. Okay, so we're going to sort out the brackets first, because if you don't, you're going to make a mistake. Almost guaranteed. Okay, so just be careful with that. So open the brackets, so 6.3 times 10 and yx minus 5. I'm doing this on my calculator here. Close the brackets, multiply that by 0.2. Okay, close the brackets again. And we're going to get 1.26 times 10 to the minus 5. Plug the rest of it into your calculator and you'll be fine. You'll get the marks for this. And if you do that, it'll be 2.45. So we'll just highlight that one there. So that's our weak acid there. Okay, so we have the first part done. And that's this part here. We're asked the second part of it there, is what is the concentration of sulfuric acid that has solution that has the same pH. Now, as soon as I see sulfuric acid, okay, some alarm bells start ringing, okay? So sulfuric acid, H2SO4. Now you should know two things about sulfuric acid. The first thing is that it's a strong acid. Okay, it's an incredibly strong acid. And the second thing is it's a dibasic acid. That means it's going to give up 2 H plus protons. Okay, I can't stress that enough. That's going to be coming up in a moment there. Okay, so I'm just going to highlight that for now. Okay, we'll come back to that now later on. Okay, first things first though, let's do out a formula. So pH of a strong acid is simply going to be pH equals minus log base 10 and then your H plus ion concentration there. And the question actually is reading is what is the concentration of sulfuric acid? So we're looking for this. That must mean we have the pH, and it says that has the same pH and as the one as of up here. So the pH is 2.45. 2.45 equals minus log base 10, your H plus there. Okay, so students find this tricky here in terms of how do you go and bring the log across. Now, if you bring that log across, okay, you have to type it into your calculator like so. You're going to type in shift or second function, okay, shift, and then you're going to type in minus, shift log, I should say. So shift log and then minus 2.45. The minus is coming from the minus over here. Okay, so it's just going to be shift, then press log, and then press minus 2.45. And that will equal to your H plus concentration here. Okay, some calculators might have second function. So second function log minus 2.45. Okay, and if you do that out, I'm going to do that with my calculator now. Minus 2.45, you're going to get your concentration to be 3.55 times 10 to the power of minus 3. So our 3.55 times 10 to the power of minus 3 equals our H plus concentration here. Okay, now this is the important part here. We must remember that it is a dibasic acid, as we have over here. Okay, so it's actually donating 2 of these protons. Okay, so this value here really is representing it's only representative of these 2 protons. We must figure out what it is for 1 proton. Okay, so all you're going to do there is the same thing all the time. It's 3.55 times 10 to the minus 3. You divide that by 2. Okay, and that in fact is going to be our true concentration. So if we divide that by 2, I'm getting 1.77 times 10 to the power of minus 3. And I'm going to highlight that there. So that's actually my answer overall. Okay, and it's always dividing for down here. Okay, as soon as you get your value over here, just divide it by 2. Okay, if it's a dibasic acid. If it's a monobasic acid, you don't need to do anything. And if it was a tribasic acid, which very rarely comes up, I think I've only ever seen it on pre-papers, okay, all you do there is you divide it by 3, okay, and you'll be told that, okay, if it was a tribasic acid, okay, that'd be too mean not to tell you. But for sulfuric acid, they didn't tell you 2 things, okay, they didn't tell you if it was a strong acid or not, okay. Now you could have assumed it was strong acid because it didn't give you the Ka, okay, but they also didn't tell you the chemical formula for it, H2SO4. So I said it before in my video lessons there that you do need to know some chemical formulas for acids and bases, and I have a slide there in my my video or my presentation, whichever one you're using, that will tell you the ones that you need to know off by heart. Okay guys, so look, I hope this helps a small bit with your pH and indicators calculations.